faculty. Before we begin the section, let me introduce you to Viskool. Viskool is an online learning platform that helps NEET aspirants like you to achieve your dream of becoming a doctor. We provide both online and offline classes. But what's the best part? We are providing recorded classes so learning fits your schedule. You can revise as many as times you want. So don't wait, join Viskool. Welcome to Viskool family. In this section, we are going to study about Rutherford's model of atom. From Thomson's plum pudding model, he suggested that atom is a uniform positive sphere in which the electrons are embedded in it like raisins. Rutherford wanted to prove it experimentally, so he carried out alpha particle scattering experiment. Now, what is alpha particle? Yeah, it's doubly charged helium nucleus, Ha2+, okay? So, to prove the model of J.J. Thomson, Rutherford have done alpha particle scattering experiment. So let's see what is alpha particle scattering experiment. This is alpha particle source, okay? Now he directed the alpha particles from the alpha particle source to fall on a gold foil. Now to observe what is happening here, he placed a photographic plate around the gold foil and intervals of the photographic plate was coated with the fluorescent material, that is zinc sulfate. Okay. Now, if an alpha particle come and hit the photographic plate, it will produce a flash of light. Okay, this is experimental setup. Here have an alpha particle source. He directed the alpha particles to come and hit on the gold foil. To observe what is happening here, he placed a photographic plate and intervals of the photographic plate was coated with a zinc sulfide. Okay, now according to J.J. Thomson, atom is having a uniform positive sphere. So this is positive, alpha particle coming is also positive, like that repel each other. So Rutherford expected large flash of light on the front side. Okay. Now, let's see whether the expectations were meted. Let's see what happens or really happens. So, this is the experiment. You can see the alpha particle source, you can see the gold foil, you can see the photographic plate. Okay, alpha particle is coming from the alpha particle source. Okay, alpha particle is coming from the alpha particle source and hit the gold foil. Now, you can observe that there is a large flash at the back side of the gold foil. Now, there are very small flashes on the front side. From this experiment, he made some observations. Most of the deflections were on the back side, right? That means most of the alpha particles passed through the gold foil. Now, there was a very little flash on the front side. So, very few alpha particles were deflected by small angles. Now, if there were 20,000 alpha particles, one alpha particle bounced back. Those were the observations, okay? Which was the first observation? Most of the alpha particle passed through the gold foil without any deflection. Very few alpha particles, that is a small fraction of particles, were deflected by small angles. Very few particles bounced back. Based on this observation, Rutherford made some conclusion. Most of the alpha particle passed through the gold foil, right? That means most of the space inside an atom will be empty. Now, very few alpha particles were deflected by small angles, right? So, there is a very dense positive charge at the atom. The positive charge occupies a very small volume because only a very few alpha particles were deflected back, right? Now, the volume of the nucleus is negligibly small as compared to the volume of the atom, okay? For example, imagine a big football ground and you are placing a very small football on the center of the ground. The size of the football is very small as compared to the big ground, right? Similarly, the volume of the nucleus, that is positively charged space, is very small as compared to the volume of the atom. So, he proposed that radius of the atom will be 10 raised to minus 10 meter. Then radius of the nucleus will be 10 raised to minus 15 meter. Now, based on the observations and conclusion, he proposed planetary model of atom. He said that atom is like a solar system. Now, what really happens in a solar system? Yeah, sun is at the center, the planets are revolving around the sun in the circular orbits, right? This is what happens in the solar system. Similarly, according to Rutherford, in atom, there is a positively charged dense nucleus at the center. Now, the electrons are moving around the nucleus in a circular path called orbits, like solar system. In solar system, sun is at the center and planets are revolving around the sun in the circular path called orbit. Similarly, in an atom, there is a nucleus, positively charged nucleus. The electrons are moving around the nucleus in the circular path called orbits. Okay, yes. So these are the features of nuclear model. The positive charge and most of the mass at the atom is concentrated in a very small portion called the nucleus. Now the electrons move around the nucleus at a very high speed in a circular path called orbit. The model resembles a solar system. Now the electrons and nucleus are held together by electrostatic force of attraction. Okay, the electrons are negatively charged, nucleus is positively charged, so they will be held together by electrostatic force of attraction. These are the features of nuclear model. So you got the observation, you got the conclusion, and you got the features, right? Yeah. Now there were some drawbacks for this model. First one, it could not explain the stability of the atom. By the time Rutherford proposed the model, Maxwell came up with the electromagnetic theory. According to this theory, an accelerated charged particle will emit energy in the form of radiation. Now, electron is charged, right? Now, when electron is moving around the nucleus, it is an acceleration. So, what happened? This electron will emit energy in the form of radiation and finally it will collapse to nucleus. So, atom will collapse. Now, does it really happen? No, right? Atom does not collapse at all. So, Rutherford could not account for electromagnetic theory, so he could not explain the stability of atom. Rutherford atom model failed in the view of electromagnetic theory proposed by Maxwell. According to Maxwell's theory, a charged particle when accelerated emit energy in the form of electromagnetic radiation. According to Rutherford's model, electrons are revolving around the nucleus. This means that electrons would be in the state of acceleration all the time. Since electrons are charged particles, electrons revolving in an orbit should continuously emit radiation. As a result, it would slow down and would no longer be able to withstand the attractive force of the nucleus. Hence, it would move closer and closer to the nucleus and would finally fall into the nucleus by following a spiral path. But we know that atom is stable, so he could not account for this. Thus, Rutherford's model failed to explain the stability of atom. And he could not explain the hydrogen spectrum. You will study about hydrogen spectrum in your coming classes, okay? And it says nothing about the distribution of electrons around the nucleus and their energies. This was the drawbacks of Rutherford's model. So, experiment, observations, conclusions, and model and the drawback. It's clear, right? So theory part, here we come to the end of the theory part. Now it's practice time. Let's do some NEET based questions from this portion. Okay. First one, Rutherford's experiment on scattering of alpha particles showed for the first time that atom has nucleus, electron, proton, neutron. Which is the correct answer? Yeah, of course, nucleus, right? From the Rutherford's alpha particle scattering experiment, it showed that atom has nucleus. So option A is the right answer. When alpha particles are sent through the metal foil, most of them go straight through the gold foil because option A, alpha particles are much heavier than the electron. B, alpha particles are positively charged. C, most part of the atom is empty space. D, alpha particles move with a high velocity. Yeah. Most of the alpha particle pass straight to the gold foil. That means most of the space in an atom is empty. Most part of an atom is empty space. Option C is the right answer. Now, calculate the radius of the nucleus of an atom having mass number 64. You have a formula for the radius of the atom. R equal to R naught A raised to 1 by 3. A is the mass number. R naught is 1.2 FM. That is 1.2 into 10 raised to minus 15 meter. Okay. So you can calculate R value, right? R will be equal to R0. Mass number is given as 64. So 64 raised to 1 by 3. That is cube root of 64. What is the cube root of 64? Yeah, it's 4, right? 4 into 4 into 4 is 64. So it will be 4 or not. So 1.2 into 4, that is 4.8 FM is the right answer. This formula is important and you should remember the value of R0, that is 1.2. Okay, yes. Now, if the diameter of two different nuclei are in the ratio 1:2, then the masses are in the ratio. Diameter, we have studied a formula for radius, right? Yeah, what was the formula? R equal to R0 A raised to 1 by 3. Now, diameter, what is the formula for diameter? It's 2 times radius, right? So, if you want to take the ratio, it will be 2R divided by 2R. That is 2R naught. That is 2R0 A raised to 1 by 3 divided by 2R0 A raised to 1 by 3, right? You can cut the common terms. So, the ratio will be A raised to 1 by 3 divided by A raised to 1 by 3. That is, the ratio of diameters will be equal to ratio of the mass number, cube root ratio. Okay, yeah. So, here the ratio of diameter is given as 1 by 2. 1 by 2 will be equal to A1 by A2 raised to 1 by 3. That is cube root. So 1 by 8, we are going to take cube, okay? We want to eliminate this cube root. So we take cube on both sides. 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8. So 1 by 8 is A1 by A2. So the ratio of A1 by A2 is 1:8. So 1:8 is the right answer for the problem. So here we have come to the end of this section. Hope this section was easy and clear for you. So until next chemistry class, thank you guys. Bye bye.